Hello everyone. Today I'm here again with another chapter of class 10 mathematics, and today I'm going to discuss quadratic equation. Now in quadratic equation we are going to discuss here about the basics of it. Then we'll be talking about the different methods by which we can solve a quadratic equation. Following which we'll talk about the nature of roots of the quadratic equation, and then we'll be also solving questions based on quadratic equations. Moving to the first part, let's talk about the quadratic equation. So an equation which is of the form of ax square plus bx plus c equal to 0, where a is not equal to 0 is known as quadratic equation, where a, b and c are real numbers. Now in this case, one more thing we need to know about the coefficients a, b and c is, here a is known as leading coefficient, or we can say quadratic coefficient. B is known as linear coefficient, and C is known as constant term. So this is what the quadratic equation is, and when the quadratic equation is written in this form, it is also known as the standard form of quadratic equation. Now one more thing needs to be remembered, that if a equals to 0, b equals to 0 and c equals to 0, then it becomes an identity. Moving to the next part, let's talk about how we can identify whether an equation is a quadratic equation or not. So we know that a degree of a quadratic equation is 2. So we will be taking the questions given and we'll be solving it. If the degree of the equation is 2, we'll be saying it as a quadratic equation. Otherwise, it will not be a quadratic equation. So if you'll take the first one here, that check whether the following are quadratic equations or not. So on solving x minus 2 whole square plus 1 equals to 2x minus 3, what we'll be getting is that this will be x square minus 4x plus 4 plus 1 equals to 2x minus 3, which will be equals to x square minus 4x plus 5 minus 2x plus 3 equals to 0, and that will become x square minus 6x plus 8 equals to 0. So as we can see here, the degree of the equation is 2. We can say therefore it is a quadratic equation. Moving to the second question, it is given that x plus 2 whole cube equals to x cube minus 4. So let's solve it. If we'll solve, what we'll get using a plus b whole cube identity, it will be a cube plus b cube, that will be 8, plus it will be 3a square into b plus 3a into b square, which will be equals to x cube minus 4. Here x cube and x cube can be cancelled. We'll get here that 8 plus this will be 6x square plus it will be 12x plus 4 equals to 0, which will give us 6x square plus 12x plus 12 equals to 0, and so we can say that it is a quadratic equation. As we can see, the degree of this equation is also 2. In case the degree of the equation is not 2, we'll say it is not a quadratic equation. Moving to the next part, let's talk about the roots of the quadratic equation. So as we all are aware that in the polynomial chapter we have discussed about the zeros of the quadratic polynomial. So what is called to be the zeros of quadratic polynomial? The same is said to be the roots of quadratic equation. Now here when we talk about the basic definition of it, then we can say, let us suppose alpha is a root of quadratic equation, then it will satisfy the quadratic equation. That means if alpha is the root of the quadratic equation ax square plus bx plus c equals to 0, then a alpha square plus b alpha plus c will be equals to 0. Next, what we'll be doing is we'll be also checking with an examples, check whether x equals to minus 2 is roots of the quadratic equation 7x square minus 3x plus 4 equals to 0 or not. So in order to check it, what we are going to do is we'll be substituting the value of x equal to minus 2 into the equation and we'll see whether it satisfies or not. So in this case, we'll take 7 into minus 2 whole square minus 3 into minus 2 plus 4 equals to 0, which will give us that 7 into 4, 28 plus 6 plus 4 equals to 0. That is, we'll get 38 equals to 0, which is not true. Therefore, we can say that x equals to minus 2 is not the root of the equation. So this is how we can check whether a given value is the root of a given quadratic equation or not. Let's talk about one more question where it is saying that if x equal to 3 is one root of the quadratic equation x square minus 2kx minus 6 equal to 0, then find values of k. So in this case we'll say since x equals to 3 is a root of the equation x square minus 2kx minus 6 equals to 0, therefore 3 square minus 2k into 3 minus 6 will be equals to 0, which will be 9 minus 6k minus 6 will be equals to 0, and we'll get here 3 equals to 6k, so k will be equals to 3 upon 6, which will be half. So this is how we can find out the value of unknown if the root of the equation is given. Moving to the next part, let's talk about how we can solve a quadratic equation. So we can solve a quadratic equation by two methods here. One will be the factorization method and the other method will be the quadratic formula method. So what is factorization method? In the factorization method, what we are going to do is we are going to factorize the given equation and then equate each of the factor to 0 in order to obtain the solution of quadratic equation. Remember, when we say solution of quadratic equation, it means the roots of quadratic equation. Now here, we know that the quadratic equation is of the form of ax square plus bx plus c equals to 0, where a is not equal to 0. Now if a is not equal to 0, then what are the other possibilities are there? So in that case, if I will talk about that ax square plus bx plus c equals to 0 where a is not equal to 0, then either b will be 0 or c will be 0 or both will be 0 or none of them will be 0. So let's talk about the different cases. So if you talk about the first case where b and c both are 0. So in this case what will happen, it is a simple one to solve. We'll take x square equals to 0 upon a, and so x will be 0. Second case, if you will take where ax square plus bx equals to 0, so here we'll take x common, we'll get ax plus b equals to 0. Now equate each factor to 0, we'll get x equal to 0 or ax plus b equals to 0. From here we'll get x equals to minus b upon a and also x equals to 0. So we'll get two zeros here. One is the 0 and the other is minus b by a, which is also known as solution of the quadratic equation. Next, when you talk about the third case where ax square minus c equals to 0 and c is greater than 0, and in this case b is equals to 0. So we can rewrite it as root ax whole square minus root c whole square equals to 0. Now using a square minus b square identity, we can write it as root ax plus root c into root ax minus root c equals to 0, and on equating each factor to 0, we will get root ax plus root c equals to 0 or root ax minus root c equals to 0. So from here on solving, we'll get x equals to minus root c upon root a, which will be negative of root c upon a, or we'll get the value of x as root c upon root a, which we can write it as root c upon a. So we'll get two values of x. One will be negative root c upon a and the other will be positive root c upon a. Moving to the next part where neither a, b or c are 0. So in that case, what we are going to do is we'll be taking the product of a and c, and then we will split the middle term, that is the coefficient of x, in two parts such that their sum should be equals to b, and in this case b1 into b2 should be equals to a into c. Once we have got that b1 and b2 value, we will split the b into two parts of b1 and b2, and so we'll get four terms. Now taking two terms together, we will group and factorize. So in that case, what will happen? We'll get ax square plus b1x plus b2x plus c equals to 0. Now we'll take the group of two terms together. Then after taking common and factorizing, equate each factor to 0 in order to obtain the roots of the quadratic equation. Now let's see that what is quadratic formula. So quadratic formula is also a way by which we can find out the roots of the quadratic equation without factorizing it. In that case, what we'll be doing is, for a given quadratic equation, we will take the value of a, b and c, and those values we will substitute in this formula in order to obtain the roots of the quadratic equation. Now here, one thing needs to be remembered, that the application of it will be there, but the proof of it will not be there from the exam point of view. But we are just going to discuss that. Let's see how we can get to this formula. So how we can get it? We have ax square plus bx plus c equals to 0. What we'll do is we'll divide both sides by a. So dividing both sides by a, which is the coefficient of leading term, we'll get x square plus b upon ax plus c upon a equals to 0 upon a, that will be equals to 0. Now we will rewrite the terms in order to write it in the form of something like x plus or minus k whole square equals to some p square. That means we are trying to convert the LHS into the perfect square expression. So it will be a square of a linear polynomial. So for that, we'll take x square plus we will rewrite b upon ax as 2 into x into b upon 2a. So if you check here, we have just rearranged, as if you cancel 2 and 2, still the value will be bx upon a. Then we will add b upon 2a whole square to both sides. As we know, we can add or subtract the same term on both sides of equality. And this is c upon a. Now on solving, we'll get x plus b upon 2a whole square equals to b square upon 4a square minus c upon a. So we'll take LCM, that is 4a square, it will become b square minus 4ac, and on solving we'll get x plus b by 2a equals to plus minus square root of b square minus 4ac upon 4a square, which can be written as x equals to minus b upon 2a plus minus square root of b square minus 4ac upon square root of 4a square will be 2a, and so the value of x will be minus b plus minus root b square minus 4ac upon 2a. And this is how we can find out the quadratic formula, and this is the derivation of it. Moving to the questions now, let's talk about the question where we'll see that how we can find out the solution or how we can solve these questions using the methods what we have discussed. So first question is, find the roots of the following quadratic equation by factorization method. So if you'll talk about the first question here, that we have to find the solution of x square minus 3x minus 10 equals to 0. So if you go with the splitting of middle term, this is x square minus 3x minus 10 equals to 0. We can take the product of 10 and 1, ignoring the sign for the time being. It will be 10 into 1, 10. Now 10 we can write it as 5 into 2, as its difference is 3. So we can write the middle term as minus 5x plus 2x minus 10 equals to 0. Now grouping the terms, we'll get x common from the first two terms plus 2 common from the next group of term. It will be x minus 5 equals to 0. That means it will be x minus 5, which will be x minus 5 into x plus 2 equals to 0. And on equating each factor to 0, we'll get the value of the roots. So here the value of roots are 5 and minus 2. Next, if you talk about the second question, it is root 2x square plus 7x plus 5 root 2 equals to 0. So if we will split the middle term here, if we'll take the product of 5 root 2 into root 2, that will be 10, and 10 can be written as 5 plus 2 is 7 and 5 into 2 is 10. So we are going to write this as root 2 x square plus 2x plus 5x plus 5 root 2 equals to 0. Now taking common from group of terms, we'll get root 2x, it will be x plus root 2, and 5 common here, x plus root 2, which is equals to 0. Further, we can see that x plus root 2 is a common factor between these two terms, so we can write it as root 2x plus 5 equals to 0. Now equate each factor to 0. We'll get root 2x plus 5 equals to 0, and so the value of x will be negative root 2, or x will be equals to negative 5 upon root 2. So these are the roots of this particular equation. Next question is, find the roots of the following quadratic equations by using quadratic formula. So let's try to find out using the quadratic formula. So first of all, in this case, what we'll do, we'll list down a, b and c value. So here the value of a is root 2, the value of b is 7, and the value of c is 5 root 2. Now we'll take quadratic formula, that is x equals to minus b plus minus square root of b square minus 4ac upon 2a. This will be minus 7 plus minus square root of b square. So that will be 7 square minus 4 into root 2 into 5 root 2 divided by 2 into root 2, which will be minus 7 plus minus square root of 49 minus 5 into 4 will be 20, and 20 into root 2 into root 2, that will become 40 upon 2 root 2, which will be equals to minus 7 plus minus root 9 upon 2 root 2, that will be minus 7 plus minus 3 upon 2 root 2, which we can write it as minus 7 plus 3 upon 2 root 2 or minus 7 minus 3 upon 2 root 2. On solving, we'll get it as minus 4 upon 2 root 2 or minus 10 upon 2 root 2, which will become minus root 2 or minus 5 upon root 2. So as we see in this case, the value of the root is minus root 2 and minus 5 upon root 2, which was the same when we have solved the same equation using factorization method. So it doesn't matter by which method you solve, you are going to get the same answer as the root of the quadratic equation. If you talk about the next question, where the value of a is 2, b is 1 and c is minus 6, let's find out the value of b square minus 4ac first. So b square minus 4ac will be 1 square minus 4 into 2 into minus 6, which will be 25, and now the value of x will become minus b plus minus square root of b square minus 4ac upon 2a, which will be minus 1 plus minus root 25 upon 2 into 2, which will be minus 1 plus minus 5 upon 4. On solving, we'll get the value of it as minus 1 plus 5, that will be 4 upon 4, that will be 1, or we'll get minus 6 upon 4, which will be minus 3 by 2. So this is how we can find out the solution of quadratic equation by using quadratic formula. So this is where we'll stop our this session today. In the next session, I'll be discussing about the natures of roots, and then we'll be also discussing the problems based on quadratic equation and also the application of it in terms of word problems. Thank you. Take care everyone.